Now, next example is prove that -1 plus I root 3 upon 2 whole raised to n plus -1 minus I root 3 upon 2 whole raised to n is equal to -1 if n is equal to 3k plus or minus 1, and value of this is equal to 2 if n is equal to 3k where k is an integer. It means here we have been asked two questions. One is addition of these two terms is equal to -1 if value of this power n is equal to 3k plus or minus 1, and the second question is addition of these two terms is equal to 2 if value of the power n is equal to 3k, right? So to get both the results, what we will do, first of all we will simplify both these terms. Now here in the first term power n is asked. Now we all know that to find out power of any complex number we have de Moivre's theorem. So if we want to use de Moivre's theorem to find out the power, then we want complex number in polar form, right? Now here the complex number is given in Cartesian form. So our first work is to convert this Cartesian form of complex number into polar form of complex number, and then we will find the power n. So I am considering the first complex number. So let's say let z1 is equal to -1 by 2 plus I root 3 by 2, and the second given number. So let's say z2 is equal to -1 by 2 minus I root 3 by 2. So I will convert this first number. Now here this first part, that is -1 by 2, it is x and the second part is y. So comparing with Cartesian form. Now what is Cartesian form? X plus iy. So we will get x as -1 by 2 and y as root 3 by 2. So here you can see that x is negative but y is positive. So when such condition occurs, that time that number is in second quadrant. You can see this is x axis, this is y axis. So when x is negative, so this part, and y is positive, this part, it means your number has to be in second quadrant. So we will find modulus and argument for this so that we can convert it in polar form. So modulus is equal to square root of x square plus y square. It means -1 by 2 the whole square plus root 3 by 2 the whole square. So it will give us root of 1 by 4 plus 3 by 4, which is equal to 4 by 4, which is equal to 1. Similarly, if I'll find out theta 1, then I'll get tan inverse of y by x. Here y is root 3 by 2 and x is -1 by 2. So we will get tan inverse of minus root 3 because 2 and 2 gets cancelled out, and root 3 upon -1 is minus root 3. So here we get it is equal to minus tan inverse of root 3, which is equal to minus. Now what is tan inverse of root 3? So if you'll see the table, then tan inverse of root 3 is 60 degree. So 60 degree is nothing but pi by 3. So we have got theta. Now it comes the formula. So when I've told you that whenever the given complex number is in the second quadrant, that time we need to add pi in the theta so that you will get argument of that particular complex number. So here minus pi by 3 plus pi. So you will get minus pi by 3 plus pi as 2 pi by 3, and this is the value of your argument. Similarly, we will find modulus and argument for the second complex number. So here we will get r equal to root of minus 1 by 2 the whole square plus minus root 3 by 2 the whole square. Here you can see that y is negative. So we will get root of 1 by 4 plus 3 by 4, which will give you 4 by 4 equal to 1. So here r is 1. Now let's find theta. So therefore theta 2 is equal to tan inverse of y by x. Now y is minus root 3 by 2 and x is minus 1 by 2. 2 and 2 gets cancelled out and we get tan inverse of root 3. Now you all know that tan inverse of root 3 is pi by 3. Now you can see here that x is also negative, y is also negative. So when this type of case arises, that time that number is in third quadrant, because you can see if it is x and if it is y, in the third quadrant x is also negative and y is also negative. So it means this number lies in third quadrant, and for third quadrant I have given you one hint that it should be theta minus phi. So here I am getting pi by 3. So here I will subtract minus pi. I will subtract pi from it. So I will get minus 2 pi by 3. So this first number, if I will convert it in polar form, I will get minus 1 by 2 plus I root 3 by 2 equal to r, which is 1. So r is 1. Cos of theta plus I sin theta. Theta is 2 pi by 3 plus I sin 2 pi by 3. Similarly, if I will convert this second complex number, which is in Cartesian form, to a polar form, then let's see what we get. So we will get minus 1 by 2 minus I root 3 by 2 equal to, now polar form is r cos theta plus I sin theta. Now r is 1, so no need to write. Cos theta, now what is theta? Minus 2 pi by 3. So cos of minus 2 pi by 3. But we all know that cos of minus 2 pi by 3 is only cos 2 pi by 3. It becomes positive. Now next plus I sin theta. Now theta is minus 2 pi by 3. We all know that sine of minus 2 pi by 3 is minus sine 2 pi by 3. So ultimately we get cos 2 pi by 3 minus I sin 2 pi by 3. So we got these two results. Now we'll substitute these two results in the given question and then we will try to prove these two results. Now in place of first complex number, I will replace this polar form of complex number. Then I will find power n using de Moivre's, and similar step I will do for the second complex number.